very warm welcome to all of you in this lecture on network analysis. We have been discussing lectures on industrial engineering, and network analysis is one of the most important topics of industrial engineering. Network analysis deals with project planning and scheduling, and on an overall basis we can say that network analysis is one of the most important tools in project management. So, different projects are there in our life. For example, suppose I want to go from Dehradun to Delhi, that is itself a project. It involves number of different activities. Different activities, maybe I get ready at my home, then I come out of my home, take a auto rickshaw to the railway station or to the bus stand, and thereafter I take a train or a bus to go to Delhi. All these small activities add up to a complete project. Similarly, in any industry, in any organization, in any institution, we have different types of projects all the time going on. If you are aware, we see in the software industry there are people called project leaders. So, what these project leaders do? They segregate the complete project into small different tasks and activities, and then these tasks and activities are accomplished by their team members, and then finally the project is clubbed together. If I give you another example of a project, we can say building a house is a very good example of a project. What we are doing in building a house? We buy a piece of land, then we make the foundation, then walls are made, flooring is done, roof is there, interior decoration is done. All these activities add up to the construction of the house. So, basically that is a project. So, building a house is also a project. Now, each of these activities will have their precedence relationships. This word precedence relationships may sound a bit difficult for you to understand at this moment of time, but with the passage of this lecture we will see what is the precedence relationship. Here, in order to understand, in order to give a very simple reasoning for precedence relationship, I would like to explain that all these activities will have their precedence. For example, we cannot make a roof without making the walls. Otherwise, it will not be a precedence thing. For example, when the foundation is not ready, we cannot erect the walls. So, the first thing to be done is the making of the foundation, then we will construct the walls, then we will do the roof, then we will do the flooring, then the interior decoration will be done. So, whenever we are constructing a house, all these activities have to be accomplished, and all these activities hold a precedence of one activity in relation to the other activity. I mean to say that one activity cannot be done until and unless its preceding activity has been accomplished. So, that basically is the crux of the project management, and how project management is important in our lives. For example, we have to take a hell amount of decisions, like I have limited amount of money available with me. Now, I have to see that on which activity I should put my money, at what moment of time which activity will be taking place. For example, if you are constructing, if you are making a particular product in your company, so which machine will be dedicated to which particular job at what moment of time, that is also falling under the broad umbrella of project management. So, project management is a very important tool which every industrial engineer or every mechanical engineer ought to know. So, today in this lecture we will discuss topics related to the basics of project management. We would try to understand what is project management like, what is the history, like how we have entered into the arena of projects or the networks, maybe network analysis. Initially, there were certain tools which were devised by the researchers and scientists, then these tools made way for the network. So, we will see that how networks evolved, we will see how we can represent the complete project in the form of a network, what are the rules to be followed when a network has to be constructed, and then we will also see that how a problem can be solved when the network is ready, what type of information we can derive once the network is ready. So, the important thing is that first we have to have a complete idea that what is the project. then we need to understand that which tasks can be divided or how the project can be divided into a large number of tasks whose accomplishment will result into the completion of the project. Then how these tasks are related to one another, which I have already explained, that is the precedence relationships, and then how these can be represented on a piece of paper in the form of a network. Then what are the rules that have to be followed when we frame the network on a piece of paper, then what are the information or what is the information that we can derive out of this network, and then finally how this information can be used by the manager of an organization for carrying out his planning activity. So, all these things we are going to see today. Maybe we will have 2 lectures on network analysis. So, first we will try to understand what is network analysis, and then we will try to solve certain problems which will be used on the basis of network analysis, certain problems which will be using the concept of networks in order to solve a simple problem. So, let us now start with understanding the networks. Now, initially let us first basically understand that what do we mean actually by project management. A project is a well defined task which has a definable beginning and a definable end and requires one or more resources for the completion of its constituent activities, which are interrelated and which must be accomplished to achieve the objectives of the project. Project management is evolved to coordinate and control all the project activities in an efficient and cost effective manner. So, these 4-5 lines add up to the complete understanding of project management. So, we will try to understand the project management concept from this definition. A project is a well defined task which has a definable beginning and a definable end. So, what do we mean to say here is there may be certain projects in which there is no end. So, that you cannot say it to be a project. For example, I have given you a very brief example of making a house or building a house. So, building a house is a very simple example of a project. Why? Because beginning is also fixed, end is also fixed, the goal is very clear that this is the kind of building or this is the kind of home which has to be made. So, it has a definable beginning and a definable end. So, it can very easily be called as a project. Now, the next point is and requires one or more resources for the completion of its constituent activities. Now, building a house, we have already identified that this can be called as a project because it has a definable beginning and a definable end. Now, we require resources for the accomplishment of these activities. Now, the house building project can be divided into a large number of small activities which I have already told you. Now, each and every activity would require certain resources. It will require certain raw materials, like it may require bricks, it may require cement, it may require certain other raw materials like concrete, etc. So, these are the resources which are required by the individual activities. Then we require manpower also, we require certain machines, certain tools also. So, house building is a project which can be divided into a number of activities, and all these activities further require certain resources for their accomplishment. So, the second point is also very clear. The completion of its constituent activities requires one or more resources, then which are interrelated and which must be accomplished to achieve the objectives of the project. Already I have explained this thing, that all these activities are interrelated, that the completion of one activity results as the beginning of another activity. So, maybe activity X is dependent on activity Y, or activity Y is dependent on activity Z. So, there are so many different activities which are interrelated to one another. So, accomplishment of one will result in the start of the other, or the finish of one will lead to the start of the other activity. So, what I mean to say is that there is a precedence relationship among these various activities. So, first 3 points are very clear. Just to summarize, because why I am addressing so much on the basics, because this is going to lead you into the complete theory of networks, and the understanding of the networks is based on this basic concept only. So, again to summarize this point, a project is a activity or a task which has a definable beginning and a definable end. Further, the project can be divided into number of small activities and tasks which require certain resources for their accomplishment, and these tasks or activity which lead to the completion or the accomplishment of the project are interrelated to one another, which means that they have a precedence relationship among one another. Now, the next point is the project management is evolved to coordinate and control all the project activity in an efficient and cost effective manner. So, the important point to understand here is that what is the need of project management. I would tell you one particular thing, that if we have unlimited resources, there is no constraint on the resources. I have huge amount of money available with me, I have a huge amount of manpower available with me, I have huge amount of resources in terms of machines and equipment available with me, then there is no need to do any kind of management, because whatever the need arises, I have sufficient stock of manpower, money, tools and equipment available which can be put into use. But that is not the case. Most of the time we are always constrained with the manpower, that only 100 people are available with me, only 10 people are available with me, only 20 people are available with me. Sometimes we have a constraint on the availability of the machines, because the machines are already working on certain other project and we also want the same machines. So, that those machines are also not available for us. Similarly, there may be crunch of the money also. We may be facing capital crunch, the money is also not available with us. So, what I mean to say is that always there are certain constraints in terms of money, in terms of manpower, in terms of other resources. So, that is why we need to evolve a technique which would help us to complete our project in the most effective, efficient and cost effective manner. So, project management is evolved to coordinate and control all project activities in efficient and cost effective manner. So, we have to complete the project within the specified time and in a very cost effective manner. That's then only, and that's the only thing that is going to lead the organization in making the profit. Now, suppose we have to launch a particular product in the market. We have outlined the different activities or tasks which will be completed for the launch of the product in the market. Suppose now we are not able to complete those activities in the specified amount of time. What is going to happen? The competitor is going up parallel in his activities with our activities. The competitor, if he is within the time, will launch his product before we are able to launch our product in the market. So, what is going to be the scenario? We would all certainly be losing certain amount of market share. Why? Because we have not been able to complete our project within the specified amount of time and the competitor has been able to do so, and that is why he enjoys more market share as compared to our company. So, a project has to be completed within the specified constraints in the most efficient and cost effective manner. So, I feel with this particular background, all of you might be able to understand that a project management and a project analysis is one of the most important tools which should be known to all the engineers and more specifically to the industrial, mechanical and civil engineers. So, now we will see certain other intricate things about project management as well as about network representation. Now, we will see what are the salient features of a project. Already I have told you what is project management, what is a project. Project is made up of number of tasks and activities, those have to be completed for the accomplishment of the project. So, now we are going to see what are the salient features of the project. On your screen you can say a project has identifiable beginning and end points, which I have already explained in the previous slide. Each project can be broken down into a number of identifiable activities which will consume time and other resources during their completion. So, all these salient features are coming from the definition of project or the project management that we have seen in the previous slide. So, first point is the project should have a identifiable beginning and end points, which I have already explained to you. Each project can be broken down into a number of identifiable activities which will consume time and other resources during their completion. I have already explained what are the other resources. These resources can be in terms of tools and equipment, in terms of certain machines. So, these are the other resources. Third point is a project is scheduled to be completed by a target date. Already I have given you one example of launching a product in the market. If that scheduled date is not met, we are going to lose a certain amount of market share in the company, in the business. So, if the market share is lost in business, it will result into huge amount of losses to the company. So, whatever target date is fixed, we have to comply with that target date. A project is scheduled to be completed by a target date. Now, that target date is fixed. If we exceed that target date, then it is going to be a loss to the company. A project is usually large and complex and has many interrelated activities, which has already been explained that all the activities and tasks which make up the complete project are interrelated to one another, and there exists certain precedence relationships among the different activities which have to be represented in the form of a network logic that we will see in the subsequent slides. Last point or the last salient feature of a project is the execution of the project activities is always subjected to some uncertainties and risks. We cannot say that the project we have planned in such a way and everything will go according to our plans only, which is not possible. Always there will be certain breakdown in the machines, certain breakdown in the smooth flow of the process. Sometimes people or the workers may not turn up. So, the planned work for that particular day, when there is mass absenteeism, will carry forward to the another day. So, all these things are the risks and the complexities in the project. So, the project completion is a very dynamic process, and every other day we will be facing a large number of problems. So, project management will help us to identify and to rectify these problems with certain tools which are a part of project management. For example, the project is lacking behind the scheduled date. Now, scheduled completion of the project is on suppose 31st of December. We are left with 15 days to complete the project, but the activities which require more than 15 days to be completed. Now, what can be done? Only 15 days are left for the scheduled completion of the project, and there are many activities which are running behind schedule and which cannot be completed before 31st of December. Then we are left with no other option, either to get the scheduled date relaxed a bit. Maybe we can say that 31st December we will not be able to complete this project. So, what can be done? So, 15 days additional time should be provided. So, we can say that we will be able to complete this project by 15th of January. But if that is not in the contract, then we have to complete the project positively by 31st of December. How that can be done? Now, we will see that which are the activities which are running before schedule and which are the activities which are running behind schedule. So, we can release certain resources from those activities which are ahead of their schedule and put those resources in the activities which are behind the schedule, so that their progress can be speeded up. And when their progress will be higher, at a higher rate they will be working, then the time for completion will automatically come down. Or we can outsource some of the activities, so that we are able to complete the project by 31st of December. If we are not able to complete the project by 31st of September, then it will invite a huge amount of penalty from our vendor or from our customer. So, we do not want to pay that penalty. So, we will do our best to avoid that penalty, so that we are able to meet the target date. So, in order to avoid the penalty, we may have to spend some more amount in order to speed up the process of completion of those activities which are behind schedule. So, why these activities are behind schedule? These are because of the fifth point or the last point on your screen. The execution of the project activities is always subjected to some uncertainties and risks. So, whenever there are certain uncertainties and risks involved, the project activities may get delayed, and this delay will result in the overall completion delay in the project. So, overall completion of the project will get delayed. So, these are some of the salient features of the project. So, if we are able to manage all these features properly, if we are able to manage the interdependence among the activities properly, if we are able to manage the uncertainty and the risks properly, then we will certainly be able to complete the project within the stipulated time and with the allocated resources. Otherwise, if we are not able to complete the project within the stipulated time with the allocated resources, if we are spending something more on allocated something more than the allocated resources, then that will add up to the cost of the project. So, we do not want that the cost of the project should be increased. So, whatever resources we have allocated, those resources should be able to complete the project within the time frame. So, that is what we require. Now, let us come to the history, how project management has evolved. Initially, there were Gantt charts. On this axis, we can say this y axis activities are there, and on x axis days are represented. So, you can say 4th day, 8th day, 12th day, then maybe 16th, 20th, 24th day, and on y axis we have activities. So, we can say activity A will start on day 1 and it will continue till day 4. Then activity B will start, which will take maybe till 12th day, this will be going. Then D will start. D and B are parallel activities, they both can start on day 4, and similarly activity C will only start when this activity is completed. So, all these activities can be represented on a time scale. So, this is one kind of representation of the activities on a piece of paper. Then we have bar charts. In bar charts also, on x axis we see we have days, and on y axis we have activities. Now, these activities you can say are represented here in the form of bars, and these are some activities, and maybe we can say on day 8th what is the completion, how much work has been completed and how much work is left to be completed. Now, similarly we have milestone charts. Why we are seeing all these charts? Because this is the way the networks have been developed. So, initially these were the tools which were used for project scheduling and project planning, but now the networks are finding wider application as compared to these charts. Now, these are the milestone charts. Now, milestone, we know that this is indicator of some certain amount of completion of a activity. So, it will indicate that this much amount of work has been completed and this much amount of work is left to be completed for the accomplishment of a particular activity and further resulting into the completion of the project. So, when all these tools are available, what is the need for going for network diagrams? So, network diagrams basically splits up the decision making process into method, logic, the order in which tasks have to be completed. So, the interrelationship is one of the most important catch points of the networks. Already we have seen, whatever we have discussed in this lecture, that most of the activities are interrelated to one another, and this interrelationship has to be incorporated into the network diagram. So, networks are very easily adaptable to this type of an interrelationship behavior between the various activities. So, this splits up the decision making process into method or logic, the order in which tasks have to be completed. So, that order is always fixed. Starting from the beginning till the end, there will be so many activities, and all these activities will be interrelated to one another. Means this activity cannot start until these two activities have been completed, or these two activities cannot start until this activity has been completed. So, that kind of interdependence or interrelationship between the activities, or what we can call it as the precedence relationship between the activities, is incorporated very easily in the form of a network diagram. Then time estimates for the time to completion can be added to each task. So, we can say that which activities can take place parallel, which activities can go at a parallel rate, which activities will be successor, which activity will be predecessor, and how much time will be required, what will be the total project completion time, what will be the individual activity completion time. So, all those things can be incorporated in the form of a network. Similarly, the resources, these can be added and then analysis can be carried out. Now, for example, let me explain. A project consists of 10 different activities. Now, all these 10 different activities when completed will result in the completion of the project. Each and every activity requires certain number of men to complete that activity. Now, suppose activity 1, 2 and 3, they require 4 persons per day, and all these activities are starting on day 1. Let me repeat, activity 1, 2 and 3 are starting on day 1, and all of them require 4 people per day. Now, what will be the requirement for the first day? Manpower requirement. Manpower requirement will be 12 people will be required on the first day if no other activity is scheduled for that day. And now, suppose we have a constraint of 10 people available. We require 12, we have 10. So, what we can do? We have to reschedule one of the activities, otherwise 12 people are required, 10 people are available, and 10 people will not be able to perform the work of 12 people. So, I mean to say is that project networks will help us to reschedule the activities in such a way, so that the manpower constraint is incorporated into the scheduling process. So, when we will relax one activity, we will relax one activity so that it will be accomplished at a later stage, and we will only plan for the 2 activities, and 4 persons per activity means 8 persons will be required, and one activity will be relaxed towards the right. Maybe it can be accomplished at a later stage, and we will find out that activity using the critical path, that if the activity is not lying on the critical path, it can be relaxed. So, what is critical path, that also we are going to understand today. So, here we need to understand is that in networks we can incorporate the concept of time, we can incorporate the concept of resources as well. So, resources in terms of manpower, I have given you an example. There may be other resources in terms of machines required, there may be other resources in terms of certain equipment required. So, all those things can be incorporated in the network, and when this network is ready, it will be helping us in solving a large number of management related problems, or on a nutshell I can say large amount of planning related problems. So, the construction of the network and then the analysis of the network is one of the most important tasks in network analysis. So, in this slide we have seen that networks are helpful in incorporating the logic into the network or into the program. Then it can incorporate the time, it can incorporate the resources. So, basically it becomes a complete entity in itself, or a complete program in itself, in which we have the interdependence among the activities, the time required for each and every activity, and the resources required for each and every activity, and then these can be optimized accordingly. Now, we come on to another important aspect, that is the network representation. Just to summarize in 3 or 4 lines, what we have discussed till now is that project management is very important. A project consists of a large number of activities or tasks whose accomplishment will lead to the completion of the whole project. Each of these tasks and activities require certain resources. These resources can be in terms of money, in terms of manpower, in terms of machine and equipment, and all these activities are interrelated to one another. That is, they have certain precedence relationships with one another. And we have seen that why networks are important. These networks are important because by representing the complete project in form of a network, we are very easily able to incorporate the logic in bit or the interdependence among the activities. We are easily able to incorporate the time aspect in the project, and we are very easily able to incorporate the resources aspect into the project. So, when this complete program or the complete project is ready, we can do the network analysis, which will be helpful to us in planning or in scheduling. So, we can plan that at what moment of time which machine will be required, how many people will be required, what amount of money will be required, and we can schedule the activities accordingly. So, now we know that network is a very important tool, and now how to represent the data whatever is available with us in the form of a network. There are certain points, we will see each and every point one by one. So, network representation, on your screen you can see a network is a graphical representation of the project activities arranged in a logical sequence and depicting all the interrelationships among them. A network consists of activities and events. So, once again I will read it. A network is the graphical representation. Graphical means that on a piece of paper we will be drawing a certain kind of a drawing which will be representing the complete project. It will be in the form of nodes and arrows, that we will see subsequently that how the network would look like. A network is the graphical representation of the project activities. Now, each and every activity will be represented by an arrow. An arrow will be having a head and a tail. So, a network is a graphical representation of the project activities arranged in a logical sequence. So, logical sequence means in the precedence relationship manner, or logically means their interdependence will be represented in the form of a network. So, logical sequence will be used in order to place the activities at their respective places in the network diagram and depicting all the interrelationships which I have already explained among them. A network consists of activities and events. So, a network consists of simple activities and events. So, how this network will look like, that we will see in the subsequent slides. So, basically what we are doing here is the complete project is divided into a large number of activities, and each and every activity will be represented by an arrow and in a logical sequence or with the precedence relationship into mind. Keeping in mind the precedence relationship, these activities will be placed at their respective places. An activity is a physically identifiable part of a project which consumes both time and resources. This I have already explained 2 times in today's lecture only, that an activity is a physical identifiable part and it will consume both time and resources. So, every activity will require some time. Maybe if we are drawing the network in terms of days, we will say every activity will require certain amount of days to be completed. Some activities may be completed in 3 days, some activities may be completed in 5 days, some activities may be completed in 10 days. So, each and every activity will require certain amount of time for completion. Similarly, each and every activity would require certain resources for its completion. So, resources may be in terms of manpower, in terms of machine. So, each and every activity would require time and resources, but there are certain activities which do not require any time and resources. What are those activities? That we will see in the subsequent slides. Now, network fundamentals means an activity or task, a work component needed to be accomplished, a task within the overall project that has a defined or definite beginning and ending point. The activity consumes time. This I have already explained. Why I am repeating all these things again and again is because these form the basis of network construction, and once the network is ready, then we do the network analysis for the help of planning activity or for scheduling the project in the best possible cost effective and most efficient manner. So, activity, by now I think everybody might have understood that what do we mean by a activity. Now, what is an event? Event designates the beginning and or ending of the activities. A point in time. So, this is a point in time, and at a particular event we will say that so many number of activities have been completed and this event has taken place. So, this is any point of time in the whole network. So, designates the beginning and or ending of activities. Already I have told. A point in time also shows the precedence relationships of the activities. So, it shows the precedence relationship of the activities. Now, what I mean to say here is that when an event has taken place, it means certain activities have converged to that event and then certain activities are starting from that event. Now, this event is turning out to be a node at which certain activities have been completed and the other activities are starting. So, the precedence is set that these activities cannot start until and unless this event has happened, because this event is resulting out to be a culminating point of certain activities which were running through and they have completed at this event, and at this event certain other activities are starting to take place. So, this will also act as one of the node or one of the logic point in the network. Then what is a network? A network is a combination of activities and events that describe the logic of the project. Now, a total network, I have already told, it is a representation of all the activities in context of their time, resources as well as their interdependence or the precedence relationships. So, a combination of activities and events that describe the logic of the project. So, logic basically means the precedence relationships, the interrelationship among the various activities. So, there is one definite starting and ending point. So, already we know that a project is a combination of tasks and activities which have a identifiable beginning and a identifiable end. So, only there will be one start point of the project, one end point of the project. In between there will be a large array of activities that would be taking place, and all the accomplishment of all these activities will finally lead to one point which will be said as the project completion. So, basically every network is made up of nodes, activities and events. So, events will be placed on the nodes and activities will be represented with the help of arrows. So, that is a simple network diagram. So, already I have told the head of the arrow represents the start of the activity and the tail of the arrow represent its end. So, we can say head of an arrow and a tail of an arrow. So, we means from the start to the beginning a arrow will be represented. So, depending upon what type of activity or what type of network diagram we want to have, we can have activities on the arrows, we can have activities on the nodes or AON or AOA. So, those type of that we are not going to go into that much depth related to the network diagrams, but we need to understand the head of the arrow represents the start of the activity and the tail of the arrow represent its end. Activity description and its estimated completion time are written along the arrow. So, on the arrow we can write that this much is the time required for this activity. That networks we will see, but what we are presently trying to understand is the representation of the complete logic of the project in the form of network diagram. So, the complete project is there, activities are there, how those are getting represented in the form of a network diagram, that we are trying to understand here. Activity description and its estimated completion time are written along the arrow. Now, on the arrow we can write the name like activity A, comma, how much time would be required, maybe 3 days suppose. So, A comma 3 on the arrow will represent that this activity is activity A, the name of this activity is A, and this would require 3 days for completion. There can be other data also which can be represented on the arrow in terms of maybe the manpower required for accomplishing this activity or the kind of tools required for accomplishing this activity. All that data can be represented. An activity in the network can be represented by a number of the ways, by number of its head and tail events like 10, 20. So, suppose the head event is 20, tail event is 10, it means 10 20 can be represented, or by a letter code. Already I have given you an example, activity can be represented by its name, maybe the name may be A or the name may be B, or all the activities may be named like A, B, C, D, E, F, G. Maybe if there are 7 activities, we can go to 7 alphabets, and all these alphabets will be representing the activities. So, activities can be represented either by the head and tail events, the number of head and tail events, and it can also be represented by the alphabets such as A, B, C, D. Now, all those activities which must be completed before the start of activity under consideration are called predecessor activities. Now, suppose activity C is dependent upon the completion of activity A and B. Now, A and B are ought to be completed before C can start. So, A and B will become the predecessor activities of activity C. Same thing is there on your screen. All those activities which must be completed before the start of the activity, in our case this is A and B. So, A and B must be completed before the start of activity C. So, C is under consideration, are called the predecessor activities. So, just again to summarize, an activity has to be started and there are certain activities which need to be completed before the start of this activity. So, the activities which are needed to be completed before the start of a known activity are called the predecessor activities to that activity. In our case, A and B are the predecessor activities for activity C. Also, it means that C cannot start until and unless A and B both have been completed. Then all those activities which have to follow the activity under consideration are called its successor activities. Now, in our example, successor of A and B is C, because C is following the completion of A and B. So, all those activities which have to follow the activity under consideration are called successor activities. So, C becomes the automatically it becomes the successor of A and B. So, when A and B will be completed at a particular event, then C will start and C will be the successor of A and B. There can be number of other examples in which we can explain that these are the successor activities and these are the predecessor activities. So, I think with the example of A, B and C, I have been able to make it very clear that what is a successor activity and what is a predecessor activity. Then in network representation, an activity which is used to maintain the predefined precedence relationship only during the construction of the project network is called a dummy activity. Now, the concept of dummy activity has been introduced in the construction of the project or the network representation. Already in the course of this lecture, I have told you that there are certain activities which do not require any time and resources. Now, these are the activities which are called as the dummy activity. So, what is the need of a dummy activity in drawing a project network? Now, dummy activity basically is an activity which is used to find out the logic and to represent the logic inside the network. Sometimes there may be a conflict in drawing the network. We are not able to very easily represent the logic or the precedence relationship or the interrelationship among the various activities following the rules of the network diagram. So, in those cases sometimes we may have to incorporate the concept of a dummy activity. So, we will see that what is a dummy activity, where it is very useful. I will explain this with the help of an example when we see the rules for drawing the network. But till now we can very easily understand this point that a dummy activity is an activity which do not require any time and resources, and it is drawn or it is incorporated or it is required in drawing the project network in order to satisfy the logic or the precedence relationships among the various activities. Dummy activity is represented by a dotted arrow and does not consume any time and resource, which already I have explained. An unbroken chain of activities between the two events is called a path. Now, between the two events, if there may be different paths, then an unbroken chain of activities between the two. On your screen you can see an unbroken chain of activity between the two events is called a path, and there is a method called critical path method that we will be discussing in the subsequent slides. So, till now what we are discussing is the representation of the complete project in the form of a network, and what are the things that are required when we construct a network for the subsequent analysis. Now, here you see, now we are going to discuss the rules for drawing the network diagram. There are certain rules that have to be borne in mind when we draw the network. So, you see the rule number 1 on your screen. Each activity is represented by one and only one arrow in the network. So, we cannot say that if certain precedence relationships have to be satisfied, activity A can start from one node and it is going here also and it is going to some other node also. So, each and every activity is represented by one and only one arrow in the network. Now, let us first see what are the arrows and what are the nodes. Now, see in this, although it is wrong, but let me explain with this diagram. Now, this is A. This arrow is representing activity A. So, here only the names of the activities are given. We can also incorporate the time and other resources into this nomenclature. In place of A, we can write A comma 3. So, this will become, this activity is activity A and it will require 3 days for accomplishment. So, A comma 3. This is the representation of activity A. This is the representation of activity B. This is a representation of activity C and this is a representation for activity D. Now, suppose this is the complete project. It is beginning here and it is ending here. So, it has a identifiable beginning and a identifiable ending, and there are 4 different activities which are resulting into the completion of the project. Now, each and every activity would require certain amount of resources to be completed, maybe certain time to be completed. So, if time is also incorporated, we can find out the longest path that would result in the completion of the project. So, why this is wrong? This is wrong because no two activities can be identified by the same end events. This is also a rule that have to be followed in construction of the network diagram. So, first rule says each and every activity has to be named independently. Each activity is represented by one and only one arrow in the network. So, A cannot have 2 arrows, only one arrow will be representing the activity A. Similarly, only one arrow will be representing the activity B. One arrow will be representing the activity C and one arrow will be representing the activity D. There cannot be 2 arrows representing the activity D. That is the first rule. Second rule is no two activities can be identified by the same end events. Now, in this case, if you see why wrong is written here, because activity B and C are having the same end events. No two activities can be identified by the same end events. So, here all activity B and C are having the same end event, which is not possible according to the rule of constructing the network diagram. So, this has to be modified. How it has to be modified? That is the right network which is shown here in green, activity A, B, C, D. Now, why this type of network was drawn? What could be the precedence relationship here? You can scratch your mind a bit. You will find that the precedence relationship here says that activity D cannot start. Activity D cannot start until activity B and activity C are completed. So, that is the kind of logic, that is the kind of precedence relationship, that is the kind of interrelationship among the various activities. So, activities of concern here are B, C and D. Now, activity D cannot start until B and C have been completed. So, this is the logic which has to be incorporated in the form of a network, but here according to rule 2 this is not the correct network. So, we have to modify this network a bit. So, how it is modified? We incorporate a dummy activity like this. This is a dummy activity. This is represented by a dotted line. Now, why this activity has been represented like this? Because in order to satisfy rule number 2. Also, it may so happen that activity D is dependent on both B and C, and with this diagram this logical precedence has been incorporated, because B is also getting completed at this event, C is also getting completed here, and then only D is beginning. There is another very good point which I would like to mention here is that there may be an activity, say I call it as activity E. Already we have activity A, B, C, D, and there is another activity, that is activity E. Now, suppose E depends on the completion of activity B. If we have to incorporate activity E in this network, from where activity E will start? Activity E will start from this point, and we can represent it like activity E is going in this direction. So, what would be the problem? If you think over it, activity E is dependent on the completion of activity B, but it is also becoming dependent on the completion of activity C, which is not the logic which is there in our network. E is only dependent on B and is not dependent on C. So, by incorporating a dummy activity here, what we have done is we have solved two problems. First is that we have now obeyed rule number 2, in which no two activities can be identified by the same end events. So, rule number 2 is also obeyed, and activity E can start from here. And activity E, when it starts from this point, it has nothing to do with activity C. Now, E if starts from here, it is only dependent on activity B, and it is not at all dependent on activity C. Now, D is dependent on B and C, and E is only dependent on activity B. So, this dummy activity has solved certain logical precedence problems which could have been there if the use of dummy activities would not have been prevalent in the construction of the network. So, rule 2 has been followed now here in this particular network. So, right network is shown and a dummy activity has been incorporated to follow rule number 2, as well as a further modification also I have told that if activity E is only dependent on B, it can start from here and it will have nothing to do with C. But if we start it from here, then it would automatically B and C would become the immediate predecessors of activity E, which we do not want. So, I think most of you might have been able to understand why dummy activities are used and what is the use of dummy activities in satisfying the logical precedence in the networks. So, with this we come to the end of this lecture on network analysis 1. Although we have started the discussion regarding the rules, but the rules could not be completed in today's lecture, which we will be covering in the subsequent lecture on network analysis 2, in which we would also be solving certain problems related to project. We would be drawing certain project or project networks, and we will see that how calculations can be done for these networks. So, we have today established what is project management. We have established networks as a very important tool for solving problems of scheduling and planning in context of project management. We have seen that what are the salient features of a project. We have seen that how a project can be represented in the form of a network, and then finally we were trying to study certain rules which have to be followed in the construction of network diagrams. So, I look forward to the next lecture in which we will be discussing certain other details related to network analysis. Thank you.